Sample return, a journey of 7 years and nearly 4 billion miles. The work of thousands culminates in this moment. Let's turn it over to our mission commentator, James Traley, to take us through the final moments. James, we're all yours.
Yeah, Lauren, buckle up and get ready for the ride of entry, descent, and landing. This is 13 minutes of crazy descent, punishing crazy deceleration of our spacecraft, starting at 27,000 miles per hour when it enters into Earth's atmosphere, and eventually slowing to a leisurely 11 miles per hour as it descends and lands on the Utah Test and Training Range.
Recovery operations. Helicopters 1 and 2 have arrived at the holding location.
So good news, our helicopters are ready to go and begin those recovery operations just as soon as we have confirmation of touchdown here. And as the sun begins to rise in the west coast, the SRC is going to be streaking across the atmosphere above San Francisco, California, about 82 miles in altitude. It's going to be coming in hot, over 5,000 degrees Fahrenheit, almost a couple seconds after it hits that atmosphere. That's about half as warm as the surface of the sun, to give you some context. But don't worry, our sample will be safe and sound within. We have a heat shield, which is made of a phenolic impregnated carbon ablator. It's a very fancy term to describe what's going on with this heat shield. It basically ablates away or burns away any kind of heat flux that develops on that outer shell, making sure that our sample is safe and cool within. Similar technology that we use with astronauts coming back from the moon or any kind of other landers that we have going into planets and moons. So we're just a couple moments away from this key moment. It's going to be very exciting next couple 13 minutes here, and you'll hear a couple callouts come in from just next door in our mission operations team as they begin to get us ready for this key moment. It's a journey of 3.86 billion miles, getting reduced to the scale of mere miles, 82 miles above the surface of the Earth in San Francisco. A couple key events are going to happen as soon as we get into the Earth's atmosphere. Very quickly we're going to deploy our drogue parachute. This is for stability, stabilizes our descent, and make sure that we are continuing to target that landing ellipse that is here in the Utah Test and Training Range. It is a 36.5 by 8 mile landing ellipse that is here, marked out for that recovery operation. You see on your screen now the mission ops team eager at the edge of their seats for that first call out of Earth atmospheric entry. Very exciting moment coming up in just a few seconds here. We're about 20 seconds away. You see the team at Lockheed now, all standing ready on the edge of their seats. This team, I'll remind you, just a few hours ago, gave that command to release the SRC on this long journey. It's been on its own for 4 hours. There's nothing we can do at this point. It's coming in, rain or shine.
EO milestone. The SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
And here we go. Start your stopwatch right now. We are 13 minutes of entry, descent, and landing. We have that expected milestone of entering into the Earth's atmosphere. We can see the team at Lockheed, and we actually have a visual now. This is from our infrared tracking camera on the WB-57, our high-altitude plane, at about 47,000 feet MSL, mean sea level, getting a great view of that SRC heating up as it enters into Earth's atmosphere. The punishing deceleration that spacecraft, that SRC is experiencing right now, as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC, a phenomenal view of that streaking SRC coming in across the sky. At this point, we have entered in over San Francisco, California, and are very quickly going to be approaching the Utah test and training range just a little bit further to the east. Entry was at
EO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning, scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 G-force, punishing deceleration from Earth's atmosphere, the drag forces
Good morning,
that are
Lola.
acting on that SRC.
Good morning, Sandy.
Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere.
Thank you,
You can
everybody.
see our high-altitude plane searching for that SRC. You can see it faintly on your screen there. Our next milestone will be expecting that drogue parachute deployment. That'll be at about 102,300 feet altitude. And as I mentioned before, that will stabilize our descent and slow us from hypersonic to subsonic speeds as we continue to target the Utah test and training range.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute, waiting to see that visual confirmation, but that is at 102,300 feet. And a side note, at this time, 8:44 a.m. Mountain Time, the OSIRIS-Apex spacecraft is at its closest approach to Earth. That will be on to its extended mission, visiting the asteroid Apophis in the year 2029, continuing this incredible mission at another world. And in just a few moments, we should enter into special use airspace at approximately 8:46 a.m. That's going to be at 10 miles off the deck here at Utah Test and Training Range. You can still see that SRC on your screen very faintly in the distance. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere. That SRC is nearly 3 feet wide, 1.6 feet tall. It's a small object, so quite a challenge to track this as it comes searing into Earth's atmosphere. And in just a few moments, we should be entering into special use airspace. This area was specifically chosen for this mission. It's a wide open, vast desert space, relatively flat, perfect to land this sample today. We did, as I mentioned, have a couple days of rain here leading up to this event, so the ground is a little bit soft. You can see our SRC. Streaking in. This is from our high altitude cam. Our next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time. That will be at around 5,000 feet elevation. We continue to track with our high altitude camera here. As I mentioned, that sample is thermally isolated within that SRC, a very complex labyrinth network of piping and tubing leading into that sample canister within that just a few years ago was on the other side of the solar system from us sampling an asteroid Bennu. The team has incredible precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12. This corrected our velocity by 3 millimeters per second. We see
PDL milestone. We have confirmed parachute deployment.
Wow. And after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange creamsicle colored parachute, just a delight, a sweet delight to see in our sky here over the Utah Test and Training Range. A phenomenal view, just wonderful to see that deployment. That is at around 5,000 feet elevation above the Utah Test and Training Range. And now this is like a marathon runner savoring that last lap here as we approach the finish, that landing in the Utah Test and Training Range. Wonderful to see that. We continue to track. This is with our high altitude camera still, that WB-57. And we should have a great view from here on the ground. We've got a variety of different tracking assets. And you saw Sophia out at the edge of that ellipse watching from Wig Mountain. The team there could potentially have a wonderful view momentarily as well. We'll continue to descend. Our next altitude descent will be at about 4,000 feet. Just a few minutes away from getting that sample from the other side of the solar system, from the surface of asteroid Bennu at sample site Nightingale to the rug. Looks like winds are relatively low. Not a lot of rocking back and forth. Those parachutes seem to be perfectly smooth coming down, that parachute there. Continuing to descend, the slight little bit of tilt back and forth of our SRC as it comes to its resting velocity of 11 miles per hour as it makes that final descent. That parachute deployment was given internally by the spacecraft. All of what you're seeing now is autonomous on board that SRC.
Oh, man. Oh, man.
And once that successfully lands, the teams will begin the next crucial phase of this mission, the sample recovery operations. They've been rehearsing for this moment for months, literally years, really, leading up to this key moment, and are ready to begin those operations to get that SRC into our portable clean room here and extract that sample canister within. According to my watch, we're about 5 minutes away from landing with our SRC. And as we heard a few moments ago, helicopters 1 and 2 are already staged and ready to begin those recovery operations just as soon as we have confirmation of touchdown. This is a variable clock, so this could be a little bit faster, a little bit slower as we get closer in. This wind speed here is a variable that is quite hard to predict, especially once you're high up in the atmosphere. We did release a weather balloon earlier on this afternoon, or earlier on this morning rather, to get a profile of our atmosphere conditions. The team puts those into various models as they prepare for this key moment. But once again, they are a little bit hard to predict, a little bit of variability. So we may kind of bounce around a little bit on that predicted OSIRIS-REx sample return capsule touchdown time. The ground really closing in now on that SRC.
PDL milestone. Helo 1 has visual on the SRC below the chute.
That is phenomenal. Let's see that view here from that first helicopter. They've got visual on the sample return capsule under parachute, that orange creamsicle colored parachute, really bright in the morning light over the Utah Test and Training Range. A great view of the SRC we can have now from our helicopter as it continues to make its final descent to the terrain below. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour. Incredible amount of deceleration there as Earth's atmosphere really helped us out quite a bit, getting that initial deceleration. our drogue parachute initially stabilizing our descent, and then ultimately that main parachute bringing us home.
Wow, from 20,000 to 11 miles an hour.
You can see right in the center of that crosshair, that is the parachute with the SRC dangling beneath.
Sorry, I'm wearing the same clothes. Everything else has fire damage.
The team on the...
It's about the only pair of clothes I have
right
right
now. WB-57 doing
EDL milestone, we have touchdown. I repeat, EDL, SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule, a journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system. Unofficial touchdown time, 8:52 a.m. Mountain. And the team can now breathe an immense sigh of relief. We now have the sample return capsule, the SRC, containing pieces of the asteroid Bennu. You see the reaction there just as they got that sample. This is the team at Lockheed celebrating that momentous achievement of getting that sample from the other side of the solar system at asteroid Bennu. When we took that sample, we were over 200 million miles away from us here on Earth.
Like
the long journey back, 1.2 billion miles from asteroid Bennu back to here with that sample has just come to a dramatic close.
Hold on.
And a little bit ahead of schedule, too. The SRC landing about 3 minutes ahead of when we had originally predicted. It was in a rush to get back here, carrying amazing amount of scientific information within. The team is the origins of our solar system and potentially the origins of life.
Wow. A sample from an asteroid before the chemicals are changed from the Earth.
We're not in the clear just yet. A key piece of the mission is about to get underway. This is the recovery operation phase. Once the team has officially confirmed the exact touchdown location, they'll be flying out on 4 separate helicopters and will operate much like a Formula One pit crew, if you will, to recover the SRC, take environmental samples at the landing zone, the LZ. Everyone has a role to play. It's going to be simultaneous action as they get that SRC recovered and begin to do an environmental safety sweep, collecting samples along the way.
This is so neat.
You see our mission ops team just next door.
It was so cool live streaming it when it took place, when the satellite bounced on the asteroid, grabbed the sample, and shot.
I once again remind you that the sample canister itself is not actually going to be opened here at Dugway. The next phase of the operation is simply to get that SRC into the portable clean room that has been specifically set up for this recovery operation. The team will then remove the heat shield protecting the SRC and its precious cargo within the entire descent through the entry, descent, and landing, remove the back shell, and then extract the sample canister within the tag sim that just a few years ago collected pieces from the asteroid Bennu.
Thank you so much.
Today, the goal is to get the sample
recovery
canister.
Operations. Helicopters 3 and 4 are leaving rig for the landing ellipse.
You see some big smiles from the team there. They are getting those helicopters out to the landing ellipse now to begin those recovery operations. The first person to approach the SRC is Stu Wiley, our on-scene commander. You see the helicopter, the last of them, taking off from the Wig Mountain just at the edge of that landing ellipse. These helicopters will have a trip out to find that exact touchdown location of the SRC and begin those recovery operations. Stu Wiley, our on-scene commander, will be the first person to approach that SRC. He'll do an environmental safety sweep checking for unexploded ordnances. As he mentioned in his interview earlier with Sophia, he understands this range. He's worked here for a number of years. He will brief the team on any possible dangers that would be presented to them as they begin those recovery operations. And then a team member from Lockheed Martin will begin to take gas and thermal readings once the area is safe of that SRC to determine whether or not it is at safe operational levels for the rest of the team to begin the recovery operations. As I mentioned, this is going to be simultaneous action. The team has prepared. They're all going to be wearing these bright white UV shirts, sample recovery shirts. And you'll see them walking out to that sample in just a few moments here once those helicopters land. A great view once again from our high altitude plane. You can see the parachute there next to our SRC. There's a possibility that there could be unexploded ordnances from that parachute. There is a mortar inside that is to fire to disconnect the parachute from the main SRC to help it come to a final rest. It's a bit challenging to see from this perspective, but there could be some potential roll marks or skid marks as that SRC came to a rest on the rugged desert surface below. As I mentioned, we did have a bit of precipitation here the other day, so that should make for a nice soft surface for that SRC, so it probably had a nice clean landing there. The team will assess as they get out there and check exactly how our conditions are for the SRC and the surrounding area. You heard Stu mentioning the team might need to wear some boots. The operations could get a little bit slippery as they begin to recover that sample. And this is a pristine sample from the ancient solar system and could hold the clues to how everything around us came to be.
And I'm going to show you guys a quick video while they're getting that set up. This is what actually took place right here. Come on, YouTube. So this is actually what took place here. So it was a crazy mission too. It kept flying and flying and flying by this asteroid, and then it finally hit, and it was so quick. I'll show you the real video. It was so quick. It just hit the asteroid, bounced in there, grabbed a sample, and shot back out. I mean, it was so... October 2020. Little thing sticking out. And it didn't go this slow. It was like boom, boom. See, it makes contact, grabs the sample, and then shoots back out. And this is all like the snap of the thing. So it blew all the loose soil away and got a sample from underneath. Well, prayers, Brandy. And this is a slowed down real image. See, it just poof. And this is slowed down. This is slowed down. Like it literally just went poof and grabbed a sample.
It's relatively flat, very smooth terrain, this desert surface. So it's perfect for bringing something back and having that nice, safe landing on the desert surface. Just a few years ago, the OSIRIS-REx spacecraft back in 2020 made its tag attempt, the touch and go.
Hold on here. There we go. Here's a little
touchdown pass over 10 football fields away and landing it perfectly in that end zone. You can see on your screen now the mission operations team. They are just next door, dialed in, ready to go. They've been monitoring the vitals of the SRC all morning. They've been there in the room, prepared and ready to go. I'm sure they are absolutely thrilled for this moment. They might even see themselves on the screen there in a second, but they are hype and ready to go. This is the Lockheed Martin team just a little bit north of us in Waterton, Colorado. They are also dialed in. They're the ones who gave that initial command this morning to release the SRC from the main OSIRIS-REx spacecraft. You just heard from Lori that OSIRIS-REx is now on its way to its extended mission. OSIRIS Apex visiting that near-Earth asteroid Apophis. A lot coming up in just a few moments. We're going to hit that key milestone of entry, descent, and landing. 13 minutes of punishing descent through Earth's atmosphere to us here in the Utah Test and Training Range. A lot coming up in just a few moments, but for now, back to you, Lauren and Jim.
Thanks, James. Very soon, NASA's Artemis program will be bringing us more cosmic samples to study by visiting a familiar beacon in the sky. Give us 60 seconds, and we'll give you the moon. Artemis 3 will be the first sample return mission of NASA's Artemis program, sampling rocks and regolith from one of 13 candidate regions on the moon, all located near the lunar South Pole. The Apollo lunar landers returned a treasure chest of samples that taught us about the history of the solar system, dating back about 4 billion years ago. Artemis missions will explore areas near the South Pole on the rim of the moon's oldest basin, the enormous South Pole Aitken Basin. Artemis will explore areas nearly 1 billion years older than those explored by Apollo. Lunar samples from Artemis 3 and future missions will help scientists interpret the impact history of the moon and Earth, as well as increase our understanding of planetary processes. OSIRIS-REx, the first U.S. mission to collect a sample from an asteroid, will return samples from asteroid Bennu. The rocks and dust collected will offer generations of scientists a window into a time when the sun and planets were forming over 4.5 billion years ago. Samples from OSIRIS-REx and Artemis could rewrite our understanding of the evolution of the solar system. And that's a look at your Artemis Moon Minute.
Our touchdown location. On your screen, just above that crosshair is the orange creamsicle colored parachute that brought us the last part of our journey down to the surface of the Earth.
Thank you, Sherry. It's all over the place, huh? I love the lounge.
You heard from Jim earlier that main parachute is about 24 feet across. Fairly large parachute that helped us decelerate on our last leg of the journey.
Yeah, I got a lot of claims.
And so we just heard a confirmation, actually, that the main parachute deployed much higher than was originally anticipated.
I was like, I'm not.
It was originally supposed to deploy at about 5,000 feet elevation, but it actually deployed at around 20,000 feet, so much higher up. So that would explain our kind of earlier touchdown time than expected.
Breathe a little better this morning. I just left these windows open and I just let that fan just.
Still has touchdown on the Utah Test and Training Range.
Hit this morning. It'd be nice to get in some different clothes too, but I'm gonna have to probably go buy some. I don't.
Team members continue to fly out to this location aboard helicopters. As I mentioned, there are 4 recovery helicopters in total. The mission operations team is continuing to monitor the situation.
Yeah, it's like I'm not letting it ruin my NASA stream.
They're the ones who are relaying us that info about that high parachute deployment, that 20,000 foot parachute deployment.
I have the availability to do so still, so I'm doing it. I forgot to turn.
They're going to be assessing the situation from their end here, relaying any possible info over to our recovery teams as they begin to make their trip out to our SRC.
Even Jizzy's like, I don't have the EvilleCJ behind me. There's nothing.
One of the first goals once the team gets out there is to safe and stow the parachute and begin to mark places of interest, as I mentioned, for that curation team to begin sampling.
I'm just glad nobody was hurt.
This is all a very well-coordinated machine, very well-oiled machine that operates in tandem. They rehearsed
day ahead of me
extensively for this moment.
So I don't know when I'll be streaming later. And I don't know if I'm still going to be able to make my trip or not, but we'll see. I was going to be leaving tomorrow morning, but
so we just heard from the team in that mission operations room that they have visual of the parachute, that orange parachute that you saw on your screen moments ago, but we do not yet have visual confirmation of the SRC itself. Team is continuing to survey the region, looking for that sample return capsule.
What? It's not under the parachute? What? It's separated from the parachute? Uh-uh. That's the kind of microphone I need right there. That one that guy's holding.
Recovery operations. Kilos 1 and 2 are in the area of the landing site and are in a search operation.
So you just heard that call out from Tim Preiser, who you see on your screen there from the mission operations room. He just announced that the Helos 1 and 2 are now at that landing site. They're pointing out something on the screen. I see some smiles. It seems like we might have potentially some more information on that SRC in the coming moments. Helos 1 and 2 will be surveying this region, looking for both that SRC and also eyeing up the region, looking at that parachute that was deployed.
Recovery operations. All of the ground supporting vehicles have left rig and are in pursuit of the landing zone.
Yeah, I switched to YouTube.
So some more team members are going to be heading out to that
I switched to YouTube full time a couple weeks ago.
That sample. The main helicopter will be actually attaching that sample return capsule once the team has it located and ready to prepare for recovery operations. They will load that on long line.
Yeah, I got about.
You can see some, once again, some team members pointing at items on the screen here. We'll hopefully get confirmation in the coming minutes.
I gotta start cleaning after this.
Of that SRC location.
Yeah.
Tim Preiser pointing at the screen now, wondering if he has any more information for us on where that sample return capsule location would be. We do have visual confirmation of that parachute, as I mentioned.
So they got visual of the parachute, but that's it.
Rich Witherspoon radioing out to the team, and now we have a view from our helicopter of the landing location. You can see the sample return capsule dead center of your screen, that kind of dark gray black object right there. And then just to the right of it, a little bit below, is our parachute. It appears to be resting on the surface. We're getting a zoom in now from our NASA helicopter, and you can see now the SRC. At last, we have a visual of it on the surface of the Utah Test and Training Range. I'm sure that is a pleasant sight for the team to see.
Recovery operations. Kilo 2 has visual on the SRC. I repeat, SRC has been located.
And we have visual on that SRC. It appears that the parachute has also disconnected. It's a little bit off from that SRC, disconnecting from the back shell. The SRC appears to be resting on its nose, that heat shield that protected it the whole way down for that entry, descent, and landing.
Resting on its nose.
Lockheed is celebrating that moment. I'm sure they're breathing another sigh of relief here. It's been a wild morning for everyone involved. They've been up since the crack of dawn, just a little bit further north from us in Waterton, Colorado. They gave the go command to actually release that SRC that you see on your screen right there from the OSIRIS-REx spacecraft about 4 hours ago. It then ventured entirely on its own and now sits on its own for us here in the Utah Test and Training Range.
Wow, that's cool, Caddy.
So now that we have visual, the teams should be able to begin the recovery operations in just a few moments.
Right there.
As I mentioned, that first person on scene will be the on-scene commander, Stu Wiley.
Like it was supposed to.
He'll be doing an environmental sweep. We're getting a nice close-up view. You can see the parachute disconnected. You can see some of the wiring of it there, just a little bit off the edge of our SRC. The SRC looks quite charred up from that entry in. That was expected as we heated up to temperatures over 5,000 degrees Fahrenheit upon entry into Earth's atmosphere. You can see a great visual of some of that rugged terrain out there. Just a sweeping expanse, very panoramic terrain at the Utah Test and Training Range. It's a great location for us to land this sample. The team looking a lot more relieved now that we actually have visual. And we should be able to begin those recovery operations shortly. Inside that sample return capsule are pieces of the asteroid Bennu.
Wow.
We'll be getting access to those samples in just a few days and actually seeing exactly what we got from the asteroid regolith.
Ooh, I can't wait to see
this mission continues to amaze me and everyone involved here. The engineering is ingenious for this mission, getting us with a robotic explorer to the edge of the solar system, collecting that sample, safely stowing it, and then and actually transporting it back here to Earth for us to open up and analyze.
And how it even landed on its nose. That's mathematics, man. That's mathematics. Like crazy.
The surface today was probably a little bit soft, so it looks like it's resting a little bit far off the actual desert. It doesn't appear to have dug in too much with that nose cone from the heat shield. You are here with us as we witness this historic moment. It's the first time the United States has delivered samples from an asteroid to Earth, and these samples will be analyzed for decades to come in laboratories around the world. And there is landing of our first helicopter at the site. Appears to have a nice soft landing. We're just probably a couple hundred feet.
Recovery operations. Kilo 1 has landed at the recovery site.
So our first helicopter, you just heard confirmation, and you can see visual confirmation of that landing. We're maybe about 100, 200 feet away, landing away from that sample. So a little bit of a hike for our team members to get out to that sample return capsule and begin our environmental safety sweep.
Yeah, why wouldn't you park the
As I mentioned, our
closer?
on-scene commander, Stu Wiley, will be the first person of the team to actually approach this sample, check the area for any unexploded ordnances, UXOs, that could possibly be out there on the range, and then also make sure that that SRC is safe for our operations team to approach and begin recovery.
Ooh, that thing is charred up.
You can see where that parachute disconnected from the top of that
was
SRC.
silver.
That is the back shield that you see right there.
It was
at the very top with that little bit of white wiring still coming out of the top. Our SRC perfectly landed there on the Utah Test and Training Range. So what you're about to see happening next is the process of recovery operations. This is a key moment of today's events to actually get that SRC from out in the desert into our portable clean room here at Dugway. It is crucial that we maintain the pristine nature of this sample that we got back from asteroid Bennu. It could hold the clues to how everything around us came to be, from the formation of the planets to origins of life here. So the team understands just how crucial the contents of that SRC is, and they're going to work as efficiently and as safely as possible to get that SRC contained, wrapped up in thermal blanketing, placed in a sample carrying fixture, and then attached with long line to our first helicopter there. It'll then be transported the long journey back here, a much more relaxing flight, I'm sure, for our SRC, to our portable clean room at Dugway. At which point the team members will extract the back shell and remove the heat shield from the SRC. It served its purpose. We're mainly now concerned with getting the contents within that sample canister containing pieces of the asteroid Reg out of that SRC. We won't actually, as I mentioned, be opening that sample canister just yet here at Dugway. The team is simply focused on getting that SRC, or the sample canister rather, on a nitrogen purge, and this is to maintain that pristine nature and prevent any kind of contaminants from the atmosphere from getting into our sample within.
Recovery operations. Kilos 3 and 4 have been cleared to land at the recovery site.
So
and the rest of the team is closely behind, ready to land at the recovery site to begin operations. This will be simultaneous action that you'll see here once we have the clearance from Stu Wiley to begin our recovery operations.
So they have to...
At least from this perspective, I'm not noticing really any drag marks or any kind of roll marks, but the team, once they approach, will mark any possible areas of interest where the SRC possibly came in contact with the rough desert terrain. All of these regions will be sampled by a recovery team and will be passed off to the sample curation team at the Johnson Space Center as they begin to unload and actually open up the sample canister there.
In 2020, this was the mission that the satellite dropped on an asteroid and grabbed a sample and shot back out. So it has a sample from an asteroid, Bennu. And if you, I played a little bit of it. Here, while they're talking about that, let me play that for you real quick. This was from an asteroid.
The team begin these operations, including the temperature of that SRC. You see it looks quite charred there. It could still be a little bit warm. As I mentioned, it heated up.
Yeah, here's the actual. Is it going to show it? This is the actual footage. This was actually like slowed down. It literally like boom, boom, real quick. But this is the actual video of it. It just grabbed a sample of an asteroid, and then here's kind of another video of it. So it was flying by an asteroid, and boom, pushed down, brushed the loose rock away, got into the asteroid, grabbed the sample real quick, and then shot back up. This is all real slowed down. This was literally like snap of a finger when all this took place. Wow. It took 3 years. It took 3 years to get from that asteroid back to Earth. 3 years. That was way far away.
Portable clean room at Dugway, at which point the team members will extract the back shell and remove the heat shield from the SRC. It served its purpose. We're mainly now concerned with getting the contents within that sample canister containing pieces of the asteroid reg out of that SRC. We won't actually, as I mentioned, be opening that sample canister just yet here at Dugway. The team is simply focused on getting that SRC, or the sample canister rather, on a nitrogen purge, and this is to maintain that pristine nature and prevent any kind of contaminants from the atmosphere from getting into our sample within.
Recovery operations. Kilos 3 and 4 have been cleared to land at the recovery site.
And the rest of the team is closely behind, ready to land
at
the recovery site to begin operations. This will be simultaneous action that you'll see here once we have the clearance from Stu Wiley to begin our recovery operations.
That's why I was like, I'm not letting this ruin my NASA stream this morning.
At least from this perspective, I'm not noticing really any drag marks or any kind of roll marks, but the team, once they approach, will mark any possible areas of interest where the SRC possibly came in contact with the rough desert terrain. All of these regions will be sampled by a recovery team and will be passed off to the sample curation team at the Johnson Space Center. As they begin to unload and actually open up the sample canister there, exploring the contents within and making sure that no possible contaminants from the surrounding landing location got into our sample. We're getting a wider view now. We should have the helicopters that have landed nearby coming into view, potentially. The team really taking extra precaution as they approach the SRC. As I mentioned, team member safety is paramount during these operations. There are possible potential areas of concern as the team begin these operations, including the temperature of that SRC. You see it looks quite charred there. It could still be a little bit warm.
See if the landlord's showing
as I mentioned, it heated up to over 5,000 degrees Fahrenheit. So as the cool desert air begins to cool down that SRC, we want to make sure that it is cool enough for our team to actually begin those recovery operations. We'll also be checking the gas levels of that SRC to make sure that it is not outgassing from the batteries within, heating up during that reentry. We'll also be making sure that there is no live voltage present. And we see from our altitude point has centered up. There's our helicopter, and it appears that we have our on-scene commander potentially walking over the landing zone. You can see some movement on the screen. It appears some team members might be approaching our SRC at this point to begin those recovery operations, the initial safety sweep.
All right, I'm going to switch to this real quick. Thank you for the article. Appreciate that. We'll switch back to the live coverage in a second. There's still why isn't it switching? Why isn't it switching? All right, cookie notice. Okay. Oh my gosh. Thank you, Caddy. This is the article. Moves? Where'd it go? Where'd the video go? Let me switch back to this. I don't know where the video went. Doug Way. NASA's first asteroid samples land on Earth after release from spacecraft. No, it's probably my shit.
Recovery team is in the vicinity, beginning their initial assessment.
I'll try to get here in a minute.
So you just heard confirmation from Tim Preiser that the team is beginning to actually approach the SRC for that initial environmental and safety sweep. You'll soon see our on-scene commander, Oscar Stu Wiley, approaching that sample return capsule. As I mentioned before, he'll be checking for any possible unexploded ordnances. You can see our mission operations team. They have been overseeing all of this morning's events, and they're going to continue. There we go. On screen, you can see front and center there, Stu Wiley, our on-scene commander, and right behind him is Victoria team. They are both wearing personal protective equipment, gas masks. That's for their own safety as they approach, as there could be potential outgassing from that sample return capsule's batteries heating up during reentry. You can see him scanning the region. He's checking for any possible unexploded ordnances, UXOs.
Recovery operations. Oscar's performing the unexploded ordnance survey.
And you just heard that he is, in fact, doing that survey right now. You can see him walking around the SRC. This is the first person to come in contact with this SRC since it was on the other side of the solar system. We had sent this on a long journey. It was OSIRIS-REx spacecraft. Finally delivering the sample, he is motioning over to Victoria team, who is shortly going to approach and begin taking some gas and thermal readings. You can see her walking over and must have given the clear for her to proceed. A little bit closer. Stu continues to pace around the surrounding area. All over here, the team will collect samples. He'll begin to place flags. You can see in his backpack, he's got a couple flags waving in the breeze. Those will be placed at areas of interest for our team members to sample once they arrive and begin those recovery operations. Victoria is now appearing to take out her thermal and gas reading devices. She's taking an initial thermal reading of that SRC as we speak, looking for it to be at an operational temperature of around 100 degrees Fahrenheit.
Lockheed Martin Safety is performing hazardous environment assessments.
You just heard. She's photographing the scene as well. So this is to
chemicals or
keep careful note of exactly the procedures that she's going through for her team.
Whatever they could kind of discover.
So the recovery operations will be getting underway shortly now that the team has conducted their initial environmental and safety sweep. Everything appears to be nominal, which is fantastic. We do, in fact, have that SRC on the ground. The rest of the team will be approaching shortly. But for now, back to you, Lauren and Jim.
So what did they get?
Wow. Thank you, James.
Oh,
Can you believe it?
OMG. Touchdown for science. What a great day.
For the folks at home, this is a huge deal, and they did it.
For the first time in history, we brought goodies back home from this kind of object in the history of humanity. So this is big.
This is so huge, and we're all breathing a big sigh of relief. Obviously, we're not completely out of the woods here, and we'll be monitoring what's going on and keeping you abreast of everything that's happening. But for now,
wow.
It's
we made
better.
it home.
A great job by that Lockheed Martin team saving that craft.
Fantastic.
When I
What a
woke up this
spacecraft.
morning,
We have
I
to
was
name her
coughing up a
specially.
lot of
Yes,
shit.
absolutely. And that capsule, everything perfect. So while the capsule was making its way to the ground, mission teams.
Recovery operations, all event covers are in place.
All right. So we're
That's
making
good.
progress.
We're
Very
making
good.
progress.
All right. So while the capsule was making its way to the ground, mission teams in the Colorado control room and the mission ops area here in Utah were, of course, riveted by the live images. These teams have watched and nurtured this mission for more than 7 years of spaceflight, and even longer in terms of construction and design. Gosh,
wow.
Amazing.
11 years since it was selected to fly. What a job, folks.
Just fantastic. A lot's happened in 7 years. All right, so let's get an update from where the action started this morning. Sophia, tell us everything.
Okay, firstly, I want to say we are so grateful that the capsule is on the ground and in good hands now. Now, from here, from Whig Mountain, I am overlooking the vast landing zone, which again is larger than the state of Rhode Island. So during that time, listening to James's commentary of the capsule coming through our atmosphere, we're all standing on the edge here, looking and scanning through the sky. But just to give you some context again of where I am, I'm about 4,000 feet up, overlooking a vast ancient seabed. So the mountains that are peppering along the edges over here, they are very muted colors. It's beautiful pastel out there. And as we're looking over through the sky, it's hard to see because there's alkaline dust from this ancient seabed. And considering that the capsule has landed on the edge of the landing zone, even though I'm as close as I could possibly be, I didn't see anything over here. I will say I'm a little disappointed, but grateful that that capsule is in the most capable hands it can be. And that is the most important thing out here. So while I didn't see with my eyes myself, we saw it on the screen and it's still a great day. So back to you, Lauren.
Yeah, this
Wow,
is the
thank
same
you,
video.
Sophia. And thankfully we got that great image from the NASA helicopter. Just well done to that team. Thank you for that. While we're keeping an eye on ongoing operations to prep for the SRC transport, we have a special message from someone who keeps a close eye on the entire manifest of the space agency's travels around the solar system.
Hey, everybody, congratulations to the OSIRIS-REx team. You did it. You designed it. You built it. And you carried out the first mission to collect a sample from an asteroid. And after a 2-year journey, it has touched down at the Utah desert. It brought something extraordinary, the largest asteroid sample ever received on Earth. It's going to help scientists investigate planet formation. It's going to improve our understanding of asteroids that could possibly impact the Earth. And it'll deepen our understanding of the origin of our solar system and its formation. This mission proves that NASA does big things, things that inspire us, things that unite us.
Recovery operations.
Yeah, they're
we can
watching
confirm that the SRC is not
Nothing is
breached.
beyond our reach.
This is the feed
mission
from NASA.
continues with incredible science and analysis going to come. But I want to thank you all for everybody that made this OSIRIS-REx mission possible. It wasn't mission impossible. It was the impossible became possible. Thank you all.
And just as a reminder, we are keeping those operational milestones going, so you will continue to hear that throughout the broadcast. Thankfully, the SRC was not breached. Fantastic news. All right, as anyone who pays just even a little attention to modern spaceflight knows, there has been more activity above the planet in recent years than ever before in human history. There are probes like OSIRIS-REx moving around the solar system, observatories looking out into deep space, and satellites closely examining the health and future of our own planet. There are also human explorers, and we are so fortunate to have two of them with us here today. Joining us now are NASA's astronauts Butch Wilmore and Suni Williams, scheduled to launch on Boeing's crew flight test aboard Starliner to the International Space Station. Butch and Suni, thank you for joining us.
Oh, we are honored to be
super
here.
exciting day. Congratulations.
Absolutely historic. How are you feeling?
Pretty amazing.
It's like, wow, this is what, dreams and imagination is fueled with. This is just amazing. So, it can go from the movies, but this is reality. And we're doing things that people couldn't even believe could happen. It's amazing. Yeah.
And also, we've both landed under capsule, under parachutes. There's not much better feeling when that parachute opens, I'm telling you. And it was maybe not equal,
obvious.
pretty close to exciting and intense. And that parachute opened, it was thrilling. Absolutely thrilling.
Yep.
Yeah, it's fantastic.
Well, that is fantastic. One of the things that I think will be really interesting is this site is being considered as one of the candidates for the Boeing Starliner crew flight.
Right, and that's actually why we're here. It just worked out in our timing for our training and as we're working on Starliner, that we could come and actually view one of our prime landing sites, which is here at Dugway. And so that's actually what brought us to the area, so we could be here and sharing the experience with you today.
And we see this has gone so well, we are ready to land.
Recovery operations.
That's the place that our flight.
The recovery team is performing their
This
safety
is a
huddle.
beautiful place. It's a beautiful day this morning. No wind. I think the capsule just came right down under the chute, and hopefully we'll have a nice soft ride, just like
Let's
this
hope
capsule
so.
too.
Absolutely. And we just got a call out that the recovery team is performing their safety operations. Everything nominal.
So
Sounds good.
you guys will be coming back and maybe someday with samples yourself brought back by humans.
Indeed.
What do you think about that?
Again, we're in that era of going beyond low Earth orbit now with humans, headed back to Moon and potentially one day to Mars with the Artemis program. And it is a thrilling time, as you mentioned earlier, so much taking place within the solar system, the near solar system now, and it's fascinating. Great time to be in human space.
Awesome.
I think I'd be a little bit nervous to go to an asteroid, so,
Wise
so
woman.
I'm
She's
super
wise.
glad that the spacecraft did it, and we'll set the pace and show us how to do it. But
Absolutely.
I think maybe you practice a little bit more before we go, because it's
Good
a
idea.
Yeah,
it's a dangerous
sounds good.
environment
Right.
learning about it. So,
So
Well,
much
Suni and Butch, thank you so much for joining us
Oh, we
today.
appreciate
Hopefully
it.
you'll stick around for more of the show.
Yeah,
all right, congratulations,
Thank you,
to
guys.
everybody out
Thank
there.
you
Really
so
appreciate it.
Yes,
Thanks,
sir.
guys. Good luck with your flight.
If you've just joined us, this is special live coverage of NASA's OSIRIS-REx Asteroid Sample Return Mission. You might be thinking, this doesn't look like a typical NASA facility. And it's not. In fact, it's because of the extraordinary capabilities that we find here, that we find ourselves in the Utah desert in the first place. We're coming to you live from Army's Dugway Proving Ground. We've got a video postcard to share that will give you a better sense of the glorious desert environment all around us. Take a look. Wow. Absolutely gorgeous. The
Unbelievable.
spaces here are vast, rugged, beautiful. I mean, you got to see a little bit from the NASA helicopter, but that was a close-up and personal look.
And look at this. We're in this place that almost looks like Mars, but on Earth, as we're recovering a capsule with the pieces of our universe that will tell us about the early time of our solar system that we can't get anywhere else. And there's the crew out there approaching that beautiful capsule that did the joyful ride from that top of the atmosphere down. 13 minutes of roller coaster riding, and they're getting it safe and ready to start bagging her to come over to the clean room here.
Wow. And explain, why do we do a land landing, as opposed to an ocean landing?
Right. So many of our crews land in the ocean, as you know from Apollo. But for this one, we need to bring it back to a place where we can contain the contamination. By landing in the desert here, we can keep the Earth's ocean, all those absolutely wonderful waters out. This is the best place to bring home this kind of capsule. And look at her. She landed perfectly. Looks like a top sitting there.
Absolutely gorgeous. Well, this isn't the first time that NASA has visited Dugway, and it certainly won't be the last. Take a look. When bringing a sample of the cosmos back to Earth, it's important to find a good landing zone that won't compromise the sample. That's why NASA partnered with the Army's Dugway Proving Ground. Its vast open space makes it ideal for the task. But OSIRIS-REx is neither the first nor the last mission to land here. In 2004, the Genesis mission landed here at Dugway, delivering our first ever samples of solar wind. In 2006, NASA landed at Dugway again, this time with a mission called Stardust, which gathered samples of interstellar dust.
Oh yeah, I remember that.
Both of these missions helped fuel our understanding of the universe and wouldn't have been possible without a safe landing zone, just like OSIRIS-REx. After today, NASA and Dugway are looking towards the future, to the Mars sample return mission that will once again be bringing a unique sample of our universe right here to Dugway Proving Ground. The U.S. Army and Air Force have been excellent hosts to us for months as we've been preparing for today's landing. That's one of many reasons I'm so pleased to welcome Colonel James Harwell, Army Commander here at Dugway Proving Ground.
Recovery operations. Nominal SRC recovery operations have begun.
An update. Okay. All right, nominal SRC recovery operations have begun. Okay.
You darn good.
All right. Okay, so today could not have gone any better. How did it, in large part due to our amazing partners here with the military, how did it look from your end?
Oh, it looked amazing. So when you talk about partnerships, this isn't just a Dugway Proving Ground effort. Though you're sitting here on Dugway Proving Ground, the capsule actually landed on the Air Force's Utah Test and Training Range. And so it's going to be brought here to Dugway before it goes to the clean room. So this is a larger effort than just the Army's Dugway Proving Ground and NASA.
And it looks like it might have landed right.
So I got a note just before this from the commander of the Utah Test and Training Range that it did land on Uter. And so there was a little bit of rivalry there. We were hoping, but it looks like it was on Uter.
Right on the boundary, though. Yeah. So close.
So we have a big collaboration at NASA with members from the Army and Navy, from the military services that have given us the opportunity to go to these great places in space ourselves as people. And can you tell us a little about the training and other fantastic things you do prepares these people to be crew for flight into space?
Yeah, so if you look at it, the Army is the greatest leadership lab in the world, the types of problems that we have to solve on a day-to-day basis. And we have some of the best workforce that is available. So here at Dugway Proving Ground, we do chemical and biological defense testing. We're part of the Army's Test and Evaluation Command. And so anytime a piece of equipment is going to go into a service member's hands, it's tested by one of our amazing members of our workforce. But we also do training here. And so it gives a chance for folks to come and do things in a realistic environment. And that's really allows them to hone those problem-solving skills.
Right. So that's why the crews are so good who come from the Army and the Navy and the Air Force.
Yeah, we'd like to point out it was an Army astronaut this week who went over who set the record.
Oh, well, there you go. Well, we couldn't let you go without wishing you a very happy birthday today. Happy birthday. Today is your birthday, and you got a piece of the solar system. How about that?
I don't think I could have gotten a better present from NASA.
No.
This is the rarest stuff we've ever had on Earth.
It is. And I mean, when we're talking about the origins of life, and that's one of the I have the coolest job in the world. A couple months ago, I was here and out on the Utah Test and Training Range, we got to go out to an archaeological site and see 12,000-year-old footprints. And now we're going to get to see the material from the origins of the solar system. I think we've set the bar pretty high.
Really
and so my kids think I'm cool today. I don't know what we're going to do to top this.
Well, we think you're pretty cool.
Yes,
too.
yes, sir.
And thank you so much for joining us. We've really loved having you.
Thank you so much.
We have a saying at NASA that the only way to reach the stars is if we all go together. The OSIRIS-REx team represents pros at the top of their game, but future explorers are just now finding inspiration in today's events. Here at the Dugway Proving Ground, students attending public school can literally say that a sample of an asteroid landed in their backyard. We visited the school to hear their thoughts about the mission and how their teachers hope it might influence their dreams of future exploration.
My name is Deborah Rockmore, and I am the librarian here at Dugway Elementary through High School. I love that Dugway is part of this. We have a very strong feeling about Dugway. It's a wonderful base. To have it be a prominent area where this is coming down is really amazing to us.
Well, I'm just glad that this little town is getting noticed. It's a big rock that has kind of like holes in it because they've been flying through the sky with fire. Because it goes really fast.
Honestly, I find it really cool because you don't really expect this stuff to happen, in your backyard. But I really wish I could see it, but I don't know. I'm going to try my hardest.
I became interested in the mission because I have the NASA app and I get daily updates on photos. And one day I saw a photo that had that Dugway, Utah titled on it. And I was like, I live there. You hear about exciting things all over the world, and it's cool to hear about, but you kind of never think that you'll be, I guess, directly or indirectly involved with it. But to know that it's just happening here within eyesight is pretty cool. Let's go, OSIRIS-REx.
Go, OSIRIS-REx.
Let's go, OSIRIS-REx.
Let's go, OSIRIS-REx.
Let's go, OSIRIS-REx.
All right, let's go, OSIRIS-REx. I love that energy.
I do too.
All right, Jim, you're a planetary geologist. How did you get into this? I mean, these kids are just at the beginning of thinking about what their career might be. I mean, how did you do this?
I think all kids are intrinsically curious at birth. My mother said I was interested in space at birth. Don't know how she knew. But in any event, I think we all are, and we follow different pathways. If you see things as beautiful as we have here in Dugway, here in Utah, you'll be inspired by the rocks and the things in space, like these special samples we've brought back, which are unique being from Bennu, but not unique in the kinds of materials we have here on Earth, thanks to other asteroid returns. These are the biggest we've ever done, and so we're excited. But I think curiosity is in all of us, and so that's really what it's all about. And these kids are ready to pick up on this energy.
Yeah, we need that future generation. All right, let's get an update from James. James, go ahead.
Yeah, Lawrence, so the mission operations team has confirmed that we are able to begin those recovery operations. You've been seeing on your screen in the bottom corner for the past couple minutes, team members beginning to head out and put flags of areas of interest where we'll want to sample for our sample curation team. And also just a note on our parachute deployment, the parachute was set to deploy based on capsule deceleration, and we actually reached that threshold earlier than predicted, and the parachute deployed appropriately. So everything was right there, working perfectly fine. We got that SRC, as you can see, successfully on the ground. It is perfectly resting on the desert terrain, and you see 3 of our team members around that capsule beginning to place flags to begin to collect samples. The team members here you see on screen are Scott Sanford, Dante Loretto, the principal investigator at the right of your screen there, and Francis McCubbin. These are key curation team members who will help us actually get a lot of these samples of the region there, environmental samples collected and ready to be passed along to our team at the Johnson Space Center for curation efforts there. This is, again, a very key part of the mission. We want to make sure that there is no contamination of that sample return capsule from any possible atmospheric or environmental conditions out at that landing zone, that landing site. And so we're going to continue these operations and actually to scoop up some of the samples, and this will work like a well-oiled machine you'll see in a few moments. Dante, who was just on your screen a few moments ago, is wearing an armband, much like a football quarterback, if you will. He'll actually be kind of reading off the play calls as they go out and go step by step to actually scoop into the terrain about an inch down into the surface of the desert, scooping out a little bit of the rock and dust that's there, placing it into a bag, photographing the whole process along the way, making note of exactly where they collected that sample from. All this information will then be passed along to our sample curation team at the Johnson Space Center as they begin to actually open up that sample canister and see exactly what we got within. This has been a long journey. It's been an incredible morning to witness this live. Just such a stunning feat of engineering to get that capsule back here to Earth with samples of the asteroid Bennu. This is why we do science, right? To get these kinds of samples.
OSIRIS-REx is a NASA mission to explore near-Earth asteroid Bennu, a remnant from the dawn of the solar system, and to return a sample of Bennu to Earth. On September 8, 2016, OSIRIS-REx began its journey to Bennu from Cape Canaveral, Florida, aboard an Atlas V rocket. It lifted off shortly before sunset, climbing eastward over the Atlantic Ocean to traverse the night side of Earth. 1 hour later, OSIRIS-REx separated from its Centaur upper stage rocket and drifted into space. It deployed its solar arrays to catch the rising sun and made a final pass over Australia before embarking on its outbound cruise to Bennu. After a year in orbit around the sun, OSIRIS-REx briefly returned to Earth in September 2017 for a gravity assist. The spacecraft passed within 18,000 kilometers of Antarctica, then turned its instrument deck toward home to capture images and spectra of the Earth and the Moon. The gravity assist bent the trajectory of OSIRIS-REx by 6 degrees, matching the orbital tilt of Bennu and sending the spacecraft on a path to catch its target. In August 2018, OSIRIS-REx began its approach phase. Its long-range camera captured the first visible light images of Bennu as a single pixel moving across a field of stars. Over the following months, Bennu grew from a pixel into a world, with OSIRIS-REx revealing its shape, rotation, and color for the first time. Now, after chasing its target for over 2 years, OSIRIS-REx is arriving at asteroid Bennu. On December 3rd, it will fire its thrusters to match Bennu's velocity and begin its preliminary survey. OSIRIS-REx will pass high above the equator and the poles, measuring Bennu's position and mass, and refining its size, shape, and spin. On New Year's Eve, OSIRIS-REx will venture close enough to Bennu to be captured into orbit by its minuscule gravity, making it the smallest world ever to be orbited by a spacecraft. In early 2019, OSIRIS-REx will break orbit to conduct a detailed survey of Bennu. First, it will carry out a mapping campaign called the Baseball Diamond. By observing Bennu at different latitudes and times of day, OSIRIS-REx will capture stereo images and identify large rocks on the surface that could pose a hazard later in the mission. In its second mapping campaign, OSIRIS-REx will observe Bennu from 7 different stations around its equator. At each station, it will take measurements from pole to pole using its mapping camera, laser altimeter, and 2 spectrometers. The combined data will provide a detailed look at Bennu's geologic features and its composition. This will improve landmark-based navigation and enable mission planners to begin looking for places to collect a sample. Following the detailed survey, OSIRIS-REx will once again enter orbit. At a radius of only 1 kilometer, Orbital B will serve as the mission's safe home orbit until sample collection. During this phase, OSIRIS-REx will globally map Bennu. It will fly in a polar orbit as the asteroid rotates beneath, enabling full coverage of the surface. Orbital B's precession, or wobble, will also be used to measure Bennu's gravity field, along with the non-gravitational forces that are slowly altering Bennu's trajectory. In mid-2019, OSIRIS-REx will begin its reconnaissance phase. It will break orbit and fly over 4 candidate sample sites at 225 meters, taking high-resolution images. Flying at such close proximity will reveal large pebbles that could pose a hazard during sample collection. Mission planners will use this information to select the 2 best sites for additional inspection. At a range of 525 meters, OSIRIS-REx will fly over the 2 final candidate sites, spectrally mapping the surface to reveal its chemical composition. This information will help mission planners determine the most valuable site for collecting the sample. Once the final site has been selected, OSIRIS-REx will begin its rehearsal phase. First, it will practice autonomous flight to a predetermined checkpoint where it will start its descent during sample collection. Next, OSIRIS-REx will practice flying to the match point. The spacecraft will lower to within 30 meters of the surface to match Bennu's speed and rotation, a necessity for safely touching the asteroid. Finally, in mid-2020, OSIRIS-REx will be ready to collect a sample of Bennu. Before it descends to the surface, the spacecraft will deploy its touch-and-go sample acquisition mechanism, or TAG-SAM, a new technology invented for the mission. When it reaches the checkpoint, OSIRIS-REx will begin its final descent. It will pull back its solar arrays for safety and approach the surface at centimeters per second, the walking pace of an insect. As the TAG-SAM touches down, it will blow high-pressure nitrogen gas into the soil, stirring up loose material. A filter within the sample head will trap rocks and dirt while allowing the gas to escape to space. Once the sample is collected, OSIRIS-REx will fire its thrusters and back away from Bennu, retreating to a safe distance with its precious cargo. Following collection, OSIRIS-REx will verify the status of the sample using a camera called SAMCAM. This visual inspection will reveal whether any large debris is still attached to the sample head, which could pose a hazard during stowage. Next, OSIRIS-REx will verify the mass of the sample. It will fully extend its TAG-SAM arm and perform a spin maneuver, measuring the change in inertia to determine the sample's mass. If at least 60 grams have been collected and the sample head is clear of hazardous debris, mission planners will command the spacecraft to stow the sample. STOWCAM will watch closely as the sample head enters the return capsule and is secured in place. OSIRIS-REx will then detach the TAG-SAM arm from the head, seal the sample return capsule, and prepare for its journey back to Earth. After departing from Bennu in early 2021, OSIRIS-REx will return to Earth in late 2023. 4 hours prior to arrival, the spacecraft will release the sample return capsule, then deflect away from Earth to its final orbit as its piece of Bennu comes home. The capsule will enter the atmosphere over the night side of Earth, streaking towards the central California coastline at over 12 kilometers per second. West of the Great Salt Lake, at an altitude of approximately 33 kilometers, the capsule will initiate its parachute sequence, stabilizing and slowing its descent. Upon landing in the Utah desert, the sample will be recovered, carefully removed from the capsule, and taken to the OSIRIS-REx Curation Facility at NASA's Johnson Space Center in Houston, Texas. This pristine material from the early solar system will be studied for decades to come, providing clues to the formation of the planets, to the evolution of Earth, and to the ingredients that were present at the origins of life.
Like it's pretty big. And again, here's the link to this video. I wanted to kind of show that just to give you guys a better visualization of the whole mission. And then again, here's the live stream. There's still they're still kind of checking things. So I'm going to drop the link to this. Thank you all for hanging out for this little episode of space exploration. I love it. So interested. It's so cool. Thank you so much for hanging out. I got some cleaning to do. So, yay. But everybody's safe. The neighbors lost everything. I just got a lot of smoke damage and my clothes. I don't know. We'll see. But if anything, if clothes is what I lost and a mattress and have to do a bunch of cleaning, you know, it could have been worse. So thank you all for your prayers, your support, your energy, your fingers crosses, and all those things. Thank you so much. I appreciate you. And I'm going to try my best to be on later tonight. And I'm going to try my best to still make this trip to Hampton County, South Carolina. So I'm not sure what's ahead for the next week or so, but after the next day or two, I should have a better idea of what's going on. So thank you guys so much. I'll see you guys here hopefully later tonight, later this evening. And I appreciate you guys. I hope you guys have a peaceful and positive Sunday. Thank you so much. This is so cool. Thank you.